Humans and machines have been working together since people first climbed out of trees and started banging rocks together. And using those machines has always led to social change. And what we're now seeing in the digital age is an interaction between humans and digital online machines that are giving them the same opportunities to develop and change society. HUMANE is a project that was started to understand the ways in which humans and machines interact, how human-machine networks operate, what are the key features of those networks, and what are the relationships that occur within it. And the intention of understanding those components was to understand how we could create roadmaps that would describe the way that networks evolve, the ways that networks can be managed and optimized to provide the best operational functionality within that network for the people working with it to achieve the goals, the objectives that they had when they started to work on that network.
In HUMANE projects, we wanted to take a theoretical approach and come up with a framework in which we could understand how these collaborative systems work.
The goal of HUMANE was to address this challenge of analyzing and designing for human-machine networks. Hence, from the outset, we stated as the overall objective of HUMANE to improve public and private services by uncovering how new human-machine networks can change patterns of interaction, behavior, trust and sociability. To obtain this, we set out to develop a framework for analyzing human-machine networks, the HUMANE typology.
So before we started the HUMANE project, there was no existing typology or classification of what we call a human-machine network. Now, lots of IT systems have been studied in different sort of research areas, but they've been more in isolation. Some have studied more the technical aspects of them, and some have studied more the social aspects of these kind of systems. So the typology is really bringing it all together. Now, typology is a way to classify systems, and in HUMANE we are trying to characterize and classify and understand human-machine networks. So we have developed a typology which has got a set of dimensions that helps us characterize these networks according to various key general features. Now, this includes the actors, the machines and the humans. It includes the interactions between them and the overall network structure. The HUMANE typology can be used in many ways. Firstly, it can be used by researchers who are trying to understand human-machine networks better. Secondly, it can be used by IT professionals who are designing human-machine networks. And actually, we've developed a tool in the project that can be used, and it's available online at the moment. So people can use this tool for characterizing their human-machine networks, and it supports understanding the implications of designs and transferring knowledge so that you learn from other networks. Now, the third use of the typology has been to help understand where human-machine networks are going in the future. So we have developed a road mapping process that uses the typology, so we are helping policymakers as well.
The tool has been developed to support the HUMANE typology and method. It far from covers all steps of the HUMANE method, but we believe that it serves to make available some of its key features. The main intended users of the tool are system designers and developers. The tool, as the typology and method, is in particular intended to support strategic considerations in the design process rather than technical implementation. If you want to give the tool a try, you find it at the HUMANE project webpage, humane2020.eu. During the first year of the project, we realized that to make the HUMANE typology and method more easily applicable, and also to share some of the analysis work we've done in the HUMANE case studies, we ought to develop an online tool for profiling of human-machine networks. The tool provides a low threshold means to analyzing human-machine networks in terms of the HUMANE typology dimensions. Such an analysis is done by scoring the human-machine network on a set of questions addressing aspects of the typology dimensions. For example, the dimension of social tie strength in a network is broken down into the aspects of intimacy, duration, and reciprocality of that relation. The profiling process is intended to trigger reflection on the characteristics of the network, of which it is important to be aware of as a designer or as a developer. Furthermore, the profile enables you to compare your network of interest to other human-machine networks in terms of profile similarity. An underlying assumption in the HUMANE project is that a comparison of human-machine networks in terms of profile similarity may support transfer of design knowledge. That is, design considerations that have shown important or useful for other networks that hold similar profile characteristics may also be important for the network that you are designing for.
The Internet has been facilitating larger-scale collaborative projects right from its inception. The web particularly has been developed primarily to allow physicists who have been working in CERN to work together and to communicate with each other in order to be able to tackle larger scale physics questions. Of course, today we have a lot more examples of collaborative projects that are happening online and that are facilitated by the Internet and the web. The analytical framework that we have developed in the HUMANE project not only allows us to understand the cases that we directly study in the project, but also it allows us to consider similar cases and even the human-machine networks that are not yet developed and compare them to the existing examples through the profiling tool that we have developed. For instance, we could find projects that are similar in concept to Wikipedia, and then we see what we could learn from Wikipedia and apply to those forthcoming projects. When you think about Wikipedia or Zooniverse, you might consider them just as online communities of contributors or editors. However, this is not a very accurate picture. When you look more closely into these projects, you will see that there are lots of machine interventions and human-machine interactions. For instance, in Wikipedia, there are lots of Wikipedia bots who go and edit articles, create links, fix typos, and in general help humans to create a better encyclopedia. Also in the case of Zooniverse, there are lots of artificial intelligence systems and interventions which make the whole collaboration more attractive and more efficient. So in both cases, we have a great deal of synergy between humans and machines, and this is the factor which makes both cases a good example of human-machine networks. For instance, in the case of Wikipedia, we have observed that human agency is the key success. All the editors who are working in Wikipedia feel that it's their own project, and that has made them quite committed to the project. This is a lesson to learn and apply it and to use it in similar projects that are yet to be developed. In the case of Zooniverse, however, we could learn other things. For instance, the use of machine agency and the use of automated systems in the Zooniverse project, which allows the developers to first pre-classify cases and then feed them to the human classifiers, allows us to increase the efficiency and the speed of the whole process. Again, this could be applied to other projects that have been identified as similar to the Zooniverse project through the profiling tool that we have developed in the HUMANE.
So I really want to talk about Evacuate, which is one of those case studies that was trying to test, if you like, quite rigorously, kick the tires of what HUMANE was producing. Evacuate itself is all about decision support, but decision support with reference to crisis management and specifically to evacuating people effectively and safely from different types of situations. So Evacuate itself is an application which sits in an operational environment, so the staff for London Underground, for example, where they have all of their screens that they're looking at the screens to monitor different areas. Now they would just look at one screen, which is Evacuate, the platform itself. Evacuate is particularly interesting and complex because you have different human players involved at different stages. On the one hand, you have the operational staff who are running and using the decision support system to help them do their job. But also you have the evacuees themselves who are monitored by the sensors attached to the decision support system, and they're the people who need to be taken out of a situation safely and effectively. So as part of the validation and the evaluation of what we were doing in HUMANE, we took specifically the profile of the human machine network and sat down with the people involved in the Evacuate project itself. We were particularly interested to understand if they could see any benefit out of representing the network through a complex relationship of different dimensions. And what we actually found is that very quickly the people that we talked to, so those involved in the Evacuate project itself, understood that this was a way of actually helping all stakeholders to understand the complexity of the network. So it gave them a way to be able to communicate across different disciplines. But in addition, what it meant was that they could understand the perspective of different stakeholders, which they hadn't thought about before.
In the final phase of the project, we produced 3 roadmaps for 3 domains: the sharing economy, e-health and citizen participation. These are domains embracing exciting technological applications which promise to bring great benefits to the economy and society. The roadmaps show us where we are now, what problems and challenges appear, and the steps we need to take in order to make these networks work more efficiently. We have set specific goals. For example, in the sharing economy, we need to motivate consumers to participate and make the sharing economy services grow in size so that they can compete with traditional services. To develop the roadmaps, first we needed to examine the broader impact and implications of human-machine networks in the selected social domains, the technical and regulatory challenges and policy interventions that can help to overcome these challenges. The roadmaps are intended primarily for policymakers who can see the broader policy interventions needed and can serve as a guide for future policies. But the roadmaps are also very helpful to designers, as they contain a lot of good design practices, to researchers as well, who are interested in the future challenges, and finally to professionals in each of the domains who are an essential part of the networks themselves. Overall, improving human-machine networks is a complex task, so collaborative effort is needed between all stakeholders to achieve specific goals.
It is very natural to think that human-machine networks and human-machine systems will be the ecosystem that we live in the future. Even today, we live with bots, with artificial intelligence systems, together in different places. We are already talking about the Internet of Things, for example. It is very important and crucial to have the theoretical understanding of these systems. They might work in practice, they might work in certain cases, but we don't want to take any risk, and that is where the role of theory becomes very important. And that was what we were after in the HUMANE project, to come up with a roadmap and to be able to understand and predict what is going to happen to the human-machine networks in the future.
Knowledge about human-machine networks is important, as ever more of our working and social lives, as well as industrial value creation, happens in such networks. Such knowledge is important for industry, for the public sector, and also for political policymaking. Our ambition for the HUMANE project is for it to serve as a step towards this needed knowledge of human-machine networks.